So when I was talking to you last week, the lecture on the browser, we were talking about how to make a web page dynamic. And we were saying that it really has kind of changed over the years from the mid-90s onwards. Initially, we were using the DOM API, if you remember, which was very kind of low-level programming. Then this library called jQuery came on the scene in the early noughties, I think, early 2000s. Extremely popular, but it had its deficiencies. And the next kind of evolution of how you program dynamic web pages came in the form of single page app frameworks. And by far and away, the most popular one of those today is a framework called React. Although that will probably change at some stage. But so I want to start covering React, and we're going to be talking about this for a couple of weeks now. 2 labs and 1 set of slides and an archive, which I will demo today. So there's a lot now in the slides, and I'm not going to get through all of them today, and that's okay. I don't expect to. So I'm going to give, I guess appropriately, just a very brief background to React, where it came from. I'm going to talk about the fact that React is very, it's narrowly focused, I suppose, if you think, when we think about it in the context of its competitors. So that's what the V in MVC is on about there. You might remember MVC from the material that you covered in Web App Development 1. JSX is this kind of secret sauce maybe that React gave to us, although JSX predates React, but React was one of the first frameworks to leverage it. And we will be writing a lot of JSX code, and it was really the use of JSX that made React such a popular framework. Then I'll talk a little bit about some of the tools that we're going to be using for this part of the module anyway. There's 2 in particular. Now, the fundamental building block of any React app is what we call a component. So we need to look at the basics of how you implement components in the React world. And the final topic there, material design, relates to styling. There's lots of styling libraries, styling as in kind of CSS libraries available to us, which are separate from React. React doesn't really care that much about styling. It lets you choose other libraries or frameworks to take care of the styling side of your app, although there are lots of styling frameworks which are purposely developed for use with React, and we will be using one of those styling libraries. So that's what we want to get through, and as I said, I won't get through all of this stuff today at all. Now, what React is, I'm saying there is, it's a framework or a library for building dynamic web user interfaces. It's kind of as simple as that. Dynamic, we know what that means now, and it's very much focused on the user interface part of a web app. Technically, React would be categorized as this single page app technology. A little bit later on, we'll see where that name comes from. It's I'm not going to try and explain it now because it won't make a whole lot of sense, but it will once we get into developing some React stuff. Now, React, like lots of tools and frameworks that we use as software developers today, React began life as a solution to a problem within a software house. And the software house, in this case, was Instagram. They developed this piece of software to solve problems that they had with their own products, if you like. Now, as we know, Instagram was acquired by Facebook. And when Facebook came across this in-house product, I'm not sure what it was called back then, they actually, fortunately, they decided they liked it, number one. They developed it a little bit more, and fortunately for us, they open sourced it back around 2012. And really, once it hit the marketplace really. Its popularity mushroomed pretty quickly. So that's kind of where React kind of came from. There are kind of nerdy discussions as to whether React is a framework or a library. I don't really care which it is, or we don't really care which it is, but just a small point. Now, so React is a single page app framework, but it was by no means the first single page app framework to hit the general public. There were lots of them out there even before React ever came on the scene. And you may have heard of some of them. Angular was extremely popular. We used to teach Angular on this module a number of years ago. Ember is another one. Backbone was probably the very first single page app framework. But back then, and then being, maybe the early 2000s, all of the single page app frameworks that did exist, they all followed this model view controller pattern. Now, you might vaguely remember model view controller from your web app development one, and really all model view controller is about is it helps you to structure your code. And you should break up your code into model parts, view parts, and controller parts. Let's not worry about it, but it was as I said, it was a pattern that software developers leveraged to help them to break their code up into different parts. Now, all of the single page app frameworks back then, early noughties, they all adopted this model view controller pattern. It actually began as a pattern for server-side code, but we are talking about client-side code, but it just made its way into the client side as well. The React framework, though, the React engineers, let's call them, the people that developed it from day one inside Instagram, they decided that they were not going to follow MVC. And also they decided that they were only going to concentrate on the V part of MVC. MVC, I probably should say, or remind you, stands for Model View Controller. They were only going to concentrate on the V part of MVC, whereas the other frameworks, its competitors at the time, tried to incorporate everything, both the model part and the C and the controller part. The model part is extremely important still. The model part is really about the data management side of your app. That's still extremely important, but the React engineers said, no, let's use another framework to take care of that. We'll just concentrate on the V part. So that was a kind of a bucking of the trend back then. Also back then, all of the other frameworks, single page app frameworks, followed a templating approach towards how you implemented the V part of your application. The React design team said they weren't going to follow that either. They were going to adopt a components approach. As it turns out, it was a clever decision because all of the single page app frameworks today now follow that trend, and they also follow this components approach. This is all by way of background now, so let's not worry too much about the terminology. You would have used templating in web app development 1. I'm not certain which templating library you would have used, but you certainly would have used it. And the arguments for the templating approach versus the components approach are kind of documented in this table. Again, I'm not going to spend a whole lot of time on it, but the kind of arguments were, number one, you were in the components approach, you were only going to be using HTML and CSS. And these were very well-founded languages and very powerful languages. Whereas in the templating approach, you had to learn another language, a kind of templating language. And it usually wasn't really as powerful as something like JavaScript or HTML. The second argument was you got a better separation of concerns between the different parts of your code. There was kind of an artificial separation of concerns in the templating model. And, also kind of linked in with this is the expressiveness of your code, or the intent of your code was much better in the components approach versus the templating approach. I'm kind of skimming over this stuff now because we really want to get to implementing stuff, but for the sake of completeness, I'm putting it in there. So React is all about building or developing components. It's not about writing templates. number one. And number two, it's all about the user interface part of your app, the V part of MVC. It doesn't care about the model part in particular. And as I said there a moment ago, the model part is still very important. But if you read around about React, there are other third-party libraries and frameworks that you can use with React, where the other ones take care of the M part of MVC. We won't be using one. We'll just kind of grow our own from to make it easy for ourselves. So a component I'm saying here is it's a unit comprised of two parts, UI description and UI behavior. By UI description, I mean, you know, what do you want to appear on the page? And that's really going to be expressed in HTML. By UI behavior, I mean, how do you want the web page to react when the user interacts with it? In other words, how do you want the UI to behave? And we're going to be implementing behavior, surprise, surprise, in JavaScript. And that's really the nice thing about React components. We're just using two foundations of the web itself, HTML and CSS, nothing more, nothing less. Whereas with the templating approach, you had to learn this templating language, as I said. And also what was nice and unique about React at the time was that your UI description and your UI behavior, even though we're using different languages, if you like, to encode both of those, you could actually put them physically into the same file, which you couldn't do with the other frameworks. So the code was co-located in the one unit or one file, and that made the developers' experience a little bit better as well, because they weren't flicking between JavaScript files, HTML files, back and forth between them. Everything they wanted to know was straight in front of them in the one file for a particular component. Okay, and there was also, so hence there was kind of tight coupling between the UI description and the UI behavior. And that led to all of these advantages. So you could compose components with other components. It was a lot easier to do that with React components than it was with a templating approach. Greater usability of your components, all that kind of good stuff. So we're kind of narrowing it down now to UI components. And in particular, for this lecture, I'm going to focus on the UI description part. The UI behavior is just going to be JavaScript, and it depends on what, we'll see that later on. But in terms of writing the UI description part of a component using React, how do we approach that? Now, I'm going to approach it from a very baseline initially, and then we'll do it kind of properly, so to speak. But when you think about the React framework, well, first of all, the React framework is broken up into a number of different packages. And the two fundamental ones is the React package and the React package and, sorry now, the React DOM package, two separate packages. And at its very simplest, the React package provides a method or a function called create element. And what we use that function for is to create a HTML element dynamically in our code. So that could be a div tag, a paragraph tag, whatever, a button, an image tag, etc., etc. So the create element method does that first. The create root method from the React DOM package, we use that to indicate where on the DOM do we want to attach an element to. Remember, I was talking last week about the browser constructs this DOM model or DOM data structure. And if you manipulate the DOM within the browser programmatically, then the browser will react to that and change what's displayed on the screen based on what changes you made to the DOM. Well, this is how we can actually indicate that we want to make some change to some DOM node. And typically what we would be saying here is, I want to attach the element that was created up here. I want to attach it to a particular place on the DOM. And by attaching it, then the browser will take care of the rest, i.e. it'll change what's the relevant pixels on the screen. Taking those two methods one by one, the create element methods, these are the arguments that you give it. You tell it what type of element you want to create, as in what type of HTML element. You might give it some properties. In particular, you might give it some CSS styling. You might associate an event handler with it. We had talked about event handlers the last day. And thirdly, you can indicate what children it has, what child elements it has. And we know that HTML allows us to nest elements within elements. You know, we could have a header and an image inside a div and all that kind of stuff. So this third argument will allow us to express that programmatically. We'll see examples in a second. Here's the thing, though. This React.create element is being used all over the place by the React runtime environment, but we never actually have to invoke it directly ourselves. And if we did, then believe me, the React framework would never have caught on and be as popular as it is. But it is there in the background all the time. And that's kind of why I think it's maybe important, just to make you aware of what's really happening down at the ground level, even though we will be programming at a much higher level. The other method then, React DOM.create root, that's much more straightforward. You just give that one argument, and the argument that you give it is a reference to an existing DOM node. And so that's where you want to attach the new element that's been created up here. You're telling it where on the DOM do you want to attach it. And we know from last week that until you attach it to the DOM, you won't see any effect on the screen. So samples, let's see some of this in action. So if I go back to the website, so if you grab this archive, download it, unzip it, and import it into VS Code, what you would be importing is the following. Now, this is actually a Node project. I remember in the very first lecture, I asked you, have you used Node? And I think the general consensus I got from you was, no, we haven't. You have actually. In the Web App Development 1, as far as I'm aware, you may have been using a cloud service called Glitch. But Glitch is actually using Node behind the scenes for you. What's different in this module now is we're going to be using Node locally on our desktop. And you always know that you're looking at a Node project if you find a file in the project called package.json. The package.json contains meta information about the project. And what we're really interested in is this section here. There's no whole lot in it though, but what this is telling us is that this particular project, Node project, is using these third-party libraries that I've just highlighted there. And surprise, surprise, React and React DOM are the two libraries that we're using. So when you import this into VS Code, the very first thing you're going to have to do is install those two libraries locally. And where they get installed is they'll really installed in this subfolder called node modules. The node _ modules folder won't exist initially, but if you bring up a terminal, which won't come up for me for some reason. Just bear with me. I'm gonna have to kill VS Code, I think, and start it again. Okay. Terminal. at last. Or maybe not. All right. Got there. Very first thing you're going to have to do is type the command npm install. And if you hit return, what npm, the npm tool does, when you install Node, you also install this thing called npm, which stands for Node Package Manager. And what the npm install command does, it goes looking for the package.json, and it goes looking to see what third-party libraries do you want to install, and it installs them locally. And it installs them locally in a subfolder called the node_modules folder. And you can see here, look, I have React and React DOM installed locally. So that's the first thing you're going to have to do. And having done that, what we really want to do is to, we can just leave that there. We needn't worry about it. You never go into the node modules folder and make any changes, but you can see in terms of the substance of this little project, I've got a bunch of HTML files, and I want to just step through them one by one. And I'm going to use the Go Live server again for this demo. So I've started my Go Live server. And if I click on the 01 HTML, which is this one here, then that's what it produces on the screen. And so we need to see how was this produced, because it was React code that produced this for us. I'll leave the developer tools open as well, even though we're not really interested in developer tools today. So if we look at the HTML file that produced what you see on the screen there, this is what it is. And nothing interesting in the head part. In the body part, you know, I need to bring in my node module, my React and React DOM libraries. But the part that we're interested in is this script here. So the script that I'm highlighting here now, that is what produced what you see on the screen. And so let's step through it one by one. So here we go, React.createElement. I'm asking it to create a H1 element. These are the properties that I want to associate it with it. And the way you interpret this is I'm associating a CSS class. Now, the React team could not use the word class because class is now a reserved word in JavaScript. So they decided to use the tag, to use the property class name to refer to CSS class that you want to associate with an element. So in future, from here on in, anywhere you see class name, just think CSS class. And I'm referring to an actual CSS class here. I'm not really that concerned about CSS in this discussion, but I'm referring to a CSS class that's actually defined in a separate little file that I have somewhere here in the style.css. Okay, nothing too interesting there. So let's not dwell on that one. Back to what we're really interested in, which is the React stuff. So create a H1 element, associate that CSS style with it. Technically, what this is here is a child of the H1 element. The child in this case is obviously the text of the H1 element. So that creates a H1 element. It doesn't attach it to the DOM though. It's just sitting there in isolation. Similarly here, it looks like I'm creating an LI element. I don't want any properties associated with it. That's its child, which is really the text of the LI element. In fact, I'm creating 3 LI elements using the React.createElement method. Next, mildly more interesting, this one here, I'm creating a UL element, no properties, but it has 3 children. And surprise, surprise, the 3 children are the LI elements in here. that I've defined previously, as in I'm nesting my li elements inside ul element, which is normal HTML, if you think about it. Next, I'm creating a div, and I want the div to have 2 children and also a bit of CSS styling. The 2 children are the header that I've created up here. Sorry, up here. Where was it? Sorry, there. The header, and also a child of my div is my unordered list. So I'm kind of building up a little network now of HTML, a header followed by a UL list, where there are 3 entries inside in the UL list, and all of that is wrapped inside a div. The final and critical part, though, in order to get this to render on the page is where I'm using React DOM.createRoot. Now, the React DOM.createRoot, what you've got to pass to it is a reference to a current node on the DOM. Now, if I scroll up and look at my web page, so here's the body, and the only DOM node that's going to be on my initial web page is this one here. It's just an empty div where I've given the div an identifier. And that's really what I'm referring to in this line here. I'm saying I want to attach some new nodes onto the existing DOM at this point here. And what do I want to attach? I want to attach this guy. And that is referring to this here. So I'm attaching the little HTML network of elements that I've programmatically created. I'm attaching them to the DOM. So it's a 2-step process. The attaching is a 2-step process. First of all, you've got to essentially kind of pick out where on the existing DOM do you want to attach some new stuff. So that's what React DOM.createRoot does for us. It returns, technically, it returns an object, okay? If you could think of this thing that I've highlighted now as an empty, a reference to an existing DOM node that you can now attach something to. And how do I attach it? I attach it by calling the render method of that reference that I've just gotten. And the render method, what you pass to it is an element that has been created by the React.create element. So here I'm just showing you programmatically how you, using the React framework, how you make a change to the existing DOM. It's very long-winded though. And if this was how we had to write React code, then believe me, React would never have caught on. This is not how we actually write it at all. But this is what's going on, as I say, at the ground level. If I simply take out, if I comment out this line here and make save it and go back to the browser, suddenly nothing is being displayed. That's because I'm not attaching anything to the existing DOM. So even though I'm building up some elements here programmatically, if I don't attach them, which I'm doing here, then nothing happens to the existing DOM. Re-enable that, save it, and that's why it displays. Okay, back to my slides. So we've just looked at the simplest and very low-level example of how you modify the DOM using the React framework. The way we've done it, though, is what we could say is that we've coded it in an imperative programming style versus a declarative approach. And the way we will actually be doing it is using a declarative approach, which we haven't seen yet, and we will see later on in this lecture, hopefully. But we'll see a lot of it in the rest of the lectures from here on in. And I mentioned this imperative versus declarative programming contrast to you before. I actually mentioned it in the previous lecture. In imperative programming, and these are just general programming terms, in imperative programming, it's all about writing a sequence of steps and explaining exactly the flow of control in your code usually in order to change some state within your execution environment. That's what imperative programming is all about. And all of the programming that you've done so far is of an imperative programming style. Whereas a declarative programming style, what you're doing is you're describing the logic that is required, and the runtime environment takes care of working out the flow of control and the step-by-step that's required to get to the end result, to carry out the computation, if you like. You wouldn't have done any declarative programming so far, I'm guessing, right? But you'll see an example of it in this module, and you'll see it as well in future. So I could say that up to now, the way I've been using the React framework is I've been using it in an imperative programming style, which isn't really much fun, to be quite honest. Before I move away from the imperative style, though, I want to look at sample 02, which is only slightly better than sample 01 in terms of the volume of code that we have to write, but it's still an imperative programming style. And before I show option 2 or sample 2, if you think about it from looking at sample 1, so let's say here I've got, I'm creating a H1 and I'm assigning it to the variable header. And the only place I use that header variable is here. So what I could do is, why not just get rid of the header variable completely, take what I've assigned to it, and just substitute that below. Copy that, and just stick it down. I need to be careful that I put it in the right place. I want to put it I want to put it there. And I'll just do a slight reformatting to make it look slightly better. Equally, I could do the exact same with list. Instead of using the list variable, I could take what's assigned to list and substitute it in. And I could keep on doing that, what's called variable substitution. So clearly now I should have gotten rid of this up here. I no longer need this now. And if I just leave it at that and I save it, it's still rendering fine for me. So I'm just making a very slight, I suppose, improvement. And if I keep on doing that variable substitution, as I said, what you finished up with is this 02 file. Essentially where I'm, nesting invocations of React.createElement. I'm nesting them inside other invocations of React.createElement. And it is worthwhile actually realizing that this still works fine. You may need to go back. Because there's so much nesting of methods inside methods, it's difficult initially to read it, but do take the time later on to ensure that you're happy that this actually is the exact same or achieves the exact same as the 01 file does. And 02 produces the same output. Yeah, so that still works fine. And understanding that will help you a little bit later on when you're kind of debugging the more declarative approach towards implementing React components. And we haven't really talked about components yet. We're just writing very raw React code. But we're still at this idea of implementing UI description using React. But as I said, it's an imperative approach, and That's not the way we do it as developers. We don't use the imperative approach. The React team gave us a declarative way of achieving this, and the declarative way is enabled by something called JSX, which stands for JavaScript extension. And essentially what JSX will allow us to do is to write our UI description using almost pure HTML, slightly different, but it's as different. The difference is as little as makes no difference. And by using this JSX syntax, which, as I said, is really HTML, it allows us to implement our UI description using more declarative style, which is a much better kind of developer experience once you get used to the syntax itself. And what's nice about JSX is that we retain the full power of JavaScript, which was one of the kind of weaknesses of the templating approach. And it allows us to tightly couple the UI behavior with the UI description, even though I'm not talking about any behavior so far, because the web page that we've just been producing so far, they're static. Now, the problem with using this JSX syntax, though, is the browsers don't actually understand it. It has to be converted back to plain old JavaScript. And by plain old JavaScript, I mean the type of JavaScript that we've seen in the two files that I've shown you so far. It has to be converted back to that. That conversion process is known as transpilation. It's the same idea as converting modern JavaScript back into pre-ES6 JavaScript or ES5 JavaScript. That was called transpilation as well. Well, transpilation includes now converting JSX syntax back into plain old ES5 JavaScript. And it's the same tool that will do the transpilation for us, this Babel tool, but it's just there in the background. Let's look at an example of this JSX syntax inside this file here, but I purposefully included error in the file name because this isn't going to work initially for us. So let's just look at the file first though. I want to achieve the same objective now. And you can see here in my script within my HTML file, I'm assigning some HTML to a variable. And then I'm doing the same before with my React DOM. Okay. I want to attach to a particular node, I want to attach this root variable that I've declared up here. Now, this kind of coding will work for us, but it won't work if you just put it into the HTML file. So I've got this code now inside of my HTML file. And if I try and load this HTML file into the browser, I get a blank screen, and on the right, you see I'm getting essentially a syntax error. And the syntax error is saying it doesn't recognize this less than character as being a valid JavaScript character in the place that I've positioned it in my code. And the particular less than or angle character that it's referring to is this one here. And true enough, that is just not normal JavaScript. No JavaScript runtime will be able to interpret that. So although this is now our first example of JSX, and as I mentioned, it's essentially HTML. We will be writing a lot of this JSX, but it has to be, it has to be converted into plain old JavaScript. It has to be converted into the type of code that we saw in the 01 and 02 files. So where does that leave us? We need to use the Babel tool to do that for us. Now, because we're only beginners, right, we could actually go to this website, babeljs.io. And what it would allow us to do is to paste in our code on the left-hand side, our JSX code, mixed with some JavaScript, and it'll generate the corresponding imperative representation of that. So maybe I could just do that, right? If I literally copy all of this from here down, the entire script. This is a very manual approach now. We won't be using this manual approach here, but this is lecture 1. So here's the babel.js.io website that I mentioned. And when you go to it, just click on the try it out link. And in here on the left, I'm going to paste my code. And on the right, it's given me the imperative plain old JavaScript equivalent of it. And surprise, surprise, look, there's lots of invocations of react.createElement all across the actual code. And so what we'll find ourselves doing is that as software developers, React software developers, we will be writing the type of code we see on the left, but the Babel tool will convert it into the type on the right, and the type on the right is what we send down to the browser, and it will be able to work. If you do go playing with this, which you really won't need to after today's lecture or this week, I suppose, to be quite honest, make sure that on the left here, you do enable the React part of the transpilation. And so I've done that beforehand. And so if I move on to the next one, which is the back. The 04, do I mention it there? Well, just a brief bit about JSX, all of which I've mentioned, I think, so far. It's a very HTML-like syntax. Technically, it's actually XML, but we could think of it as HTML. There are minor differences between JSX and pure HTML. The only one that we will ever come across is the fact that whereas in normal HTML, if we want to refer to some CSS styling, we use the class attribute on our HTML tag. We can't do that in JSX because, as I said, class is a reserved word within JavaScript. And because we're going to be mixing our JSX into a JavaScript file, when the runtime environment sees the keyword class, then it gets confused. So instead of class, we're going to be using class name. That's what the React design team decided to use. So any CSS styling associated with a JSX stroke HTML tag will use class name instead of class. And really that's the only difference that you will see between HTML and JSX. And what JSX allows us to do, as I kind of already mentioned, it allows DUI description to be coded in a declarative style and be inlined with ordinary JavaScript. So if we now move on to sample 4, I thought I mentioned sample 4 there, I didn't, but sample 4 is, in sample 4, what I'm doing here is I've got a reference to a local script, which is this one here. And that's above in my JavaScript folder. And just for your purposes, I've got two 04 files. I've got what I call the pre-transpilation and the post-transpilation version of my JavaScript. In the pre-transpilation, I have this code here. This is what we write. And the post-transpiled version of that is in this file. Okay, this is essentially what I did was I used that babel.js.io website. I pasted my code into the left-hand side, and then I copied the code that it generated on the right-hand side and put it into this file. So my HTML file is referring to the post-transpiled code. But as developers, we write the pre-transpiled code because it's much easier and cleaner kind of coding syntax. So we're getting a step closer to writing components, but we actually haven't written a component yet. Going to pause maybe for a question, just in case somebody has a question. I know I'm rattling through this now, but it's the way I've got to do it, I'm afraid. Transpilation, just a brief word about it. Fortunately, well, once upon a time, there was only one tool that was available to us, Babel. There are actually alternatives now. There's one called Vite, which is growing in popularity, but we'll stick with the original of the species. The way we can do it manually using that, what's called a REPL website. There is a command line tool that you could use as well, but that doesn't make life that much easier for us. A much better solution is where we have a web server that does it for us. So if you could imagine the Go Live server, and if you could imagine I'm writing my JSX code in a file, and every time I save that file, it would be great if the Go Live server picked up the fact that I'd made a change to it, converted it or transpiled it into plain old JavaScript and sent it down to the browser automatically for us. So I could exist in my JSX world and just do my development in JSX, and the Go Live server would take care of the transpilation for me using the Babel platform. Well, in fact, there are lots of web servers out there that will allow us to do that. Go Live doesn't do it, but we will be using another web server which takes care of it for us in that way. Third option is eventually, you're going to have to, you can imagine now if you're developing a non-trivial web app, there are going to be quite a number of JavaScript files or with JSX in them. And we don't want those files to be transpiled and sent individually down to the browser. That would be a very kind of poor performance experience. What really needs to happen is all of the JavaScript files need to be gathered up together, all of them transpiled, and somehow all of the transpiled code bundled or wrapped inside one file. And that single file then can be sent down to the browser. In addition, that single file, its kind of contents can be minified in the sense of we can get rid of any white space that's unnecessary, get rid of all the indentation and alignment, because the runtime environment, the browser doesn't really care about that stuff. All of that kind of should be done, again, kind of behind the scenes first. And it's done by what are called bundler tools. And we will be using a bundler tool, again, kind of behind the scenes, but just be aware that that is going on. So I began by saying that React is all about developing components, but we haven't actually seen a component. We've seen JSX. So what is a component in the context of React? And it actually turns out that a component is a JavaScript function, but it's a function that returns JSX. That's what makes it a React component. It can have any other logic it wants to inside in that function, but critically, it must return JSX. And that JSX becomes the part of the UI that component contributes to the overall web page, where a web page may actually be built from a number of components. And the nice thing about this this component approach is that we can actually refer to a component, even though it's just a JavaScript function, we can refer to it as if it's a new HTML tag. And sometimes I say that React is, in a sense, it's a bit like extending the HTML syntax to creating your own HTML tags. And you can see down here, you can actually do something like this, right? Supposing I've got, in the examples that I was showing you there, I was generating a list of dynamic programming languages, Java, JavaScript, Python. Not sure what the other languages, what were the other languages that I mentioned? Well, Java is the dynamically typed language. But let's supposing my web page was generating a list of dynamic programming languages with a header. And let's supposing I referred to the JSX that produced that. I put that into a component and I refer to that component as by name as dynamic languages. where dynamic languages would be the name of the function. Well, I could actually use that function name as if it's a HTML tag. See here, I'm using the HTML opening and closing angle brackets. And that's actually the way we will be using these functions that are really components, React components. And so sample 5, we eventually kind of get to writing a component. So sample 5, again, I've got a HTML file. But there's nothing too interesting in that. It's referring to, apart from React and React DOM, it's referring to a local JavaScript file. And if I go up to my JavaScript folder and use the same numbering system, I've got 205 files. One, I've decided to call 05 simple component, up to JSX. JavaScript folder. I've got a 05 simple component transpiled and a 05 simple component source. Source is what we will write. So here's our first example of a React component. And as I said, it's a function. I'm using the arrow syntax for my function declaration. I've decided to call the function dynamic languages. That's just the function name. And the function doesn't have any logic in it, if you like. You know, there's nothing going on here. It is returning something though. And what is it returning? It's returning some JSX syntax. And so this component produces this on the screen. And as before, I'm attaching the component now. In this case, I could say I'm attaching the component to an existing node on my DOM as before. And as I mentioned there on the slide, I can actually refer to the function at the top there as if it's a new HTML tag. But yet again, all of this code has to be transpiled. The transpiled equivalent of it is in this file here. And really, after today's lecture, we won't ever be looking at the transpiled version anymore, because this is what we write as developers. But what is actually sent down to the browser is this. Okay, and you know, it's back to our React.createElement stuff all over again. Where's React.createElement there? You can see it, for example. Now, again, the transpilation and all of that is still very manual in the way that I'm approaching it, which is really not a good developer experience. So we have seen the 101 example of a React component, JavaScript function that returns JSX. There are the two takeaways from the lecture so far. As usual, I never get as far as I expect to get, but so be it. I'm going to stop here now. I won't try and rush through this. So I'm going to leave it at that for today and talk to you next Thursday or Wednesday, sorry. So let me just stop sharing. Okay, folks, that's it for today. And I'll pick up the story the next day, unless there are any questions that people might have for the last minute or two that we have left. No, all right. I'll talk to you on Wednesday. Bye for now.